Alright guys, welcome back. So now we're gonna go over essentially what we did the last two videos was we looked over linear and angular velocities. So now we're gonna prove a theorem that I guess correlates both of them together. So the equation I guess proves them both after doing like derivation, all that bull crap. You get something like V is equal to R omega, where omega is the angular velocity and then R is just the radius and V is the velocity. So here's a problem that I guess correlates all this together. So let's say you have a blade. So let me draw the blade. And now let's say this is 22 inches. And let's say it is rotating at 2,500 revolutions per minute. So obviously this is going to have to be converted, and then this is, you could already get R by just halving this, which would be 11. So we can already get R is equal to 11 inches. So we already have R, but we're gonna have to get omega from this. Well, obviously you can't just plug that in and get an answer. That's not, this will not make sense. You'll get something like inches revolution per. That does not make sense. So we're gonna have to switch that. So what else did they give us? So what's the question? So essentially they want us to find the angular velocity, which is this, and then they want us to find the linear velocity, which is this. So we're basically doing each step. So now you wonder, so how do we get omega from this? So here's what we're gonna do. We're gonna convert this crap into radians per second. What this would usually be like. So omega is usually in radians per second. So how do we convert this? So first of all, we have to kind of see what we have. So we have this per minute. Well, you want to convert it to radians. The conversion, now I haven't gone over this yet, but essentially the conversion factor for revolutions to radians is going to be 2 pi over 1 rev. So 2 pi radians. So basically, for every 1 revolution, there's 2 pi. Now I can I can go to like this whole theory about why it's 2 pi. But essentially, the simple reason is that in a circle, every like revolution is 2 pi, because half of a circle is pi, and then the entire is 2 pi. So essentially, every half circle you go through is pi. So if you go another full circle, is 4 pi. If another circle is 6 pi, and etc., etc., etc. So essentially, so that's basically the theory. So going back to this, you multiply essentially this by this, you would get, so your revolutions would go away, but you still have radians per minute. You want it per second, so essentially you multiply again. Well, you divide by 60 seconds. And so once you do all those calculations, now put squiggle in because this is an approximate answer, you'll get something like 262 rats per second. I obviously rounded up, but this is basically what you would get. So now that we have radians per second, great. So now what do we do? Well, now we can find the linear velocity. Well, okay. We already found. Well, we already found the omega. So we did the first part. So this one is done. That was omega. So now we can find the linear velocity, V. So this is just 11 inches times that. And then in the end, you would get 2,880 inches per second. And this would be your answer. And that's it. Pretty simple, actually. So essentially, from this would be usually this would do it for these type of questions. This would actually be as complicated as they get, where you get given like some weird ass conversion, and you would have to convert it to radians per second. So then from there you just multiply by the radius and you get your linear velocity. So I hope you guys enjoyed this video. I'm gonna make one more video and I'll see what that will be.